Alrighty, it's time for more Desmos. So, here on this 3D graph, I have a unit sphere that's meant to resemble the Earth, and I have sliders for the time of year. That's S for season, is the time of year. I have the Earth's axis tilt. I can adjust that as a parameter, but realistically, that's about 0.41 radians. That's what that is in the real solar system. And then I have the latitude. Those are all parameters on this. Now, a little more about how Desmos works. When you make an expression with a t in it, default behavior in Desmos is to interpret t as the independent variable in a parametric. So what you see here, because this is actually this is a vector, you see. It's got three components. This is the first component, so that's the x component of the vector, and the x component of the vector is a function of t. The y component of the vector is another function of t, and the z component is another function of t. So what this is here, this is a vector-valued parametric curve, right, with parameter t, and t is the time of day. T here is varying from 0 to 2 pi, and the way it's showing up on the graph is as this green curve going around the planet. So what we're interested in, because we want to know about the transition from nighttime to daytime, we want to know about the x coordinate of that parametric. So we want just this bit. So what I've done is I've taken this and copied it over to a 2D graph over here. Never mind that for the moment. So here's this 2D plot, and just to be a little bit confusing, in order to get this to show up on Desmos, I renamed the time of day parameter to x. So x, so that it would show up on the horizontal coordinate. So x, the horizontal coordinate here in this picture, is the time of day, and y, the vertical coordinate in this picture, that's x over on this picture. Not my finest hour in naming things, but maybe it'll shed some light if I say when this green curve is positive, that means we're in daytime, and when it's negative, that means we're in nighttime. And the parameters S and A and L still stand for the time of year, the Earth's axis tilt, and latitude. So if we play with these parameters, here the time of day, the time of year, that is winter time. And as you can see in winter time, oh, and I have realistic axis tilt and latitude 0.69 radians. That is about right for Nevada City, California, according to a Google search I did. So if we adjust time of year, in the wintertime, you can see that almost 4 units out of 2 pi, we're in nighttime. So majority of the time is nighttime, which is what you'd expect for winter. Over here in summertime, the opposite happens. A majority of time is spent in the daytime. If I mess with the latitude and send us closer to the North Pole, then I get to a place where it's daytime all the time during the summer and nighttime all the time in the winter. And if I go all the way to the North Pole, the curve flattens out because on the North Pole, you don't move at all laterally based on the time of the day. You would move based on the time of the year. So if I move the time of the year, then I go into, all the time nighttime and all the time daytime. That's what you would expect on the North Pole. So let's move this back down to a more realistic latitude for Nevada City, California. So that's there. And I don't know where we're at on this curve. I didn't do that calculation. Um, this is the derivative. And the reason I want to look at the derivative is because we want to know the duration of the sunrise and the sunset. So we want to look at how fast this point is transitioning from nighttime to daytime or from daytime to nighttime. And that means we need its derivative. In particularly, we need its derivative when the green curve is at zero. So like when it's right here, that's the sunrise because that's the green curve transitioning from the back of the Earth to the front of the Earth. So if I look at this x coordinate and evaluate the derivative, I get something like 0.76, and that's going to tell me about how fast this point is moving through the twilight zone.